Today we are going to continue talking about functions and their graphs. Piecewise functions. All right, a cell phone company offers the following plan. $20 per month buys 60 minutes. Additional time costs 40 cents per minute. Now pay attention to this because they're going to give you the same set of information, and they're going to, in a little bit, they're going to expect you to be able to write this piecewise function for it. Okay, so pay attention how I write this. It says it's $20 a month buys your 60 minutes. So the function for that would be y equals 20 bucks. As long as your time does not go over 60 minutes. And obviously it's got to be more than 0 minutes. Okay, so that's where this comes from. Okay, to graph that, if you look down here on the graph, from 0 to 60, you will pay 20 bucks. If you talk 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, 70 minutes, 80 minutes, or 60 minutes, sorry, up to 60 minutes, it's only going to cost you 20 bucks. That's going to be your bill. As soon as you go over 60, you're still going to pay the 20 bucks, but you're going to pay an additional 40 cents per every minute over 60. So you have to, like, let's say you had 80 minutes. You wouldn't get charged 40 cents for 80 minutes because the first 60 are free. So you'd have to take the 80 minus 60. You'd only be paying 40 cents for the extra 20 minutes. So that's why they get this t minus 60. And then your restriction is if your time is over 60 minutes. So it's really not hard to set up. It's 20 bucks as long as your time stays under 60. It's 40 cents per minute over 60 if you go over 60 minutes. Okay, so they wrote it for us. They even graphed it for us. So if I graphed this, okay, you would, again, it's going to have this slope from here. It's going to have this slope of 0.40. So it's going to go up 40 and over 100, if you will. Okay, and that's the slope of this line. So it says, find and interpret C of 30. Well, if you're only talking for 30 minutes, you're in this restriction. So your cost is going to be 20. I don't have to do any math. It's not over 60. It's just going to be 20 bucks. If you are talking for 100 minutes, okay, C of 100 is going to be the 20 bucks. I'm 100 minutes, so now I'm in this restriction, so I have to use this equation. So it's going to be 20 plus 0.40, 100 minus 60. Because again, you're not going to get charged 40 cents for all 100 minutes. The first 60 are free, so you're only going to get charged 40 cents for the 40 minutes you went over. So then if I plug that in, I have 20 plus 0.40 times 40. My calculator, sorry, my fingers, plus 0.40 times 40, I get 36 bucks. So if you talk for 100 minutes, your bill is going to be $36. Okay? All right, so it says a cell phone company offers the following plans. Also given are the piecewise functions that model these plans. Use this information to solve exercises 79 through 80. So plan A charges you $30 a month for 120 minutes. Anything over 120 minutes costs you 30 cents a minute. So as long as your time stays between 0 and 120, your bill is going to be 30 bucks flat. Anything over 120, it's going to cost you the 30 flat fee plus 30 cents for every minute over 120. So you have to take your total minutes, take away 120 to see how much you're going to get charged for. Okay, so 9 says, simplify the algebraic expression in the second line of the piecewise function for plan A. Then use point plotting to graph the function. So if I simplify this, C of t equals 30 plus, distribute this, I'd have 0.30t minus 0.3 times 120 is 36. Combine like terms, and I have 0.30t minus 6. Okay, so if I pick some values and graph that, okay, But the only thing is you want to pick minutes that are above 120. So let's do 120. That would be 0.30 times 120 minus 6. 0.30 times 120. Enter. Minus 6. You get 30 bucks. So at 120 minutes, it's going to cost you exactly 30 bucks, which we knew. So let's do, I don't know, what do you want to start? Let's count by 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. So at 120 minutes, $10, $20, $30, $40, $50, $60, $70, $80, $90, $100, $110. So if I plot that point, 120, 30 is right there. If I do, let's do C of 140. So I'd have 0.30 times 140 minus 6. 0.30 times 140 minus 6, you get 36. So 140 would be $36. 140, 36, I don't know, about right there. Maybe not quite that high. Yeah, a little bit. Alright, and then, I don't know, let's do C, well, it's a line. So that's, all we need is 2 points. And a straight line. Okay, so there's plan A for everything over 120. Up until that point, you're just going to pay 30 bucks. Okay? So now let's do plan B, which I don't have any room to do. Alright, plan B, again, it wants us to simplify the algebraic expression on the second line and then use point plotting to graph the function. So, I apologize, I'm going to have to erase this. Let's see, to do plan B, I have 40 plus 0.30 times t minus 200. So if I distribute, I get C of t equals 40 plus 0.30 t, and 0.30 times 200 is going to be 60, so minus 60. So simplify that, it's 0.30 t minus 20. So if I point some plots, okay, again, this is for everything over 200. So if we start at 200, that would be 0.30 times 200 minus 20. Minus 20 is 40. So that ordered pair would be 200, comma 40. So 240. I should have made a bigger graph. Let's pick, what did I count by 20? So this would be 220. So let's do C of 220. 0.30 times 220 minus 20. So 0.30 times 220 minus 20 is 46. So this ordered pair would be 220, comma 46. And that's going to be at about right there. So we're doing this. Alright, we should have the same strength and slope. 200, comma 40, 220. I'll try and get on the, yeah, that's 40. 46. There we go, I was too high. 46. Yeah, we should have the same slope. Okay, and everything up to that point, up to 200 minutes, is going to cost you 40 bucks. So there's plan B. Okay? So, what do you think the better deal is? Well, up until 140 minutes, or around this point, so I'm not right on there. Bloop. Up until about, I don't know, whatever that point is, 140 something minutes, you'd be better off with plan A, because plan B is going to cost you much more. But if you talk over 140 something minutes, then plan B is going to be your better deal, because you'd pay less here than you would with plan A. So it says, write a piecewise function that models each cell phone billing plan, then graph the function. So $50 a month buys 400 minutes. That means that the cost of your plan is $50 as long as your time stays between 0 and 400. So let's let's go by hundreds. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000 minutes. And what's our price? We got $50. Let's count by tens, I guess. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. So up until 400 minutes, my price is $50. So from 0 to 400, that's the cost of your plan. Now, anything over 400 minutes costs you 30 cents extra. So my second piecewise function, sorry, you write C, you do this, C of t equals, and then you do this. There's your top one. It equals the $50 plus an extra 30 cents for any time over 400 minutes. And that's for time greater than 400. So if I plot that point, if I graph that, I need to simplify it. So 50 plus 0.30t minus 0.30 times 400 is 120. So that simplifies to 0.30t minus 70. So if I pick 400, I know I'm going to get 50. So let's pick 500. So if I do C of 500, and all I'm doing is just changing this, instead of y, it should be C of t. Sorry, I shouldn't go back and forth between function notation and not. So if I find C of 500, it'll be 0.30 times 500 minus 70. So 0.30 times 500 minus 70, I get 80. So 500 comma 80. And if I graph that, it would be all the way up here. And again, you could do the C of 400, but I know it's going to be 50, but you can do the math. 400 minus 70, I get 0.30 times 400 is 120, minus 70 is 50. So this point and this point is going to follow this line. Okay? Yeah? And then you could actually read the graph. So you could say, well, for 700 minutes, it's going to be whatever this point was that it crossed. That would be your price. Of course, my graph isn't big enough to read, but there you go. All right. So here is a 2011 federal tax rate Schedule X that specifies the tax owed by a single taxpayer. I don't think anybody actually looks at tax charts anymore because everybody does TurboTax, which automatically does everything for you. But it's smart that you should know how a tax chart works when you get old enough. Well, some of you are already working. That means you're paying taxes. Okay, so what this says is if your taxable income is over 0 but not over $8,500, that means you made somewhere between 0 and $8,500. You owe 10% of whatever your income was. Okay, of the amount over $0. If you make 850, it's over 850, but not over 34.5, then you're going to pay 15%. You're going to take 850 plus 15% of how much ever is over 8,500. So if I start looking at this piecewise function they made up, to put this in an equation, it says you're going to pay 10% of this. Basically represents your money. Your money is in between these two amounts, okay, but not over. That means this one is less than or equal to, so I could say this is for when x is greater than or equal to 0 but less than 8,500. You see how they wrote that? Less than or equal to, greater than 0. Sorry, greater than 0 but less than or equal to, because it can't be over. Okay, but it could be equal to. So they said you're going to pay 10% of your money if your money is between $0 and $8,500. If you go over $850, then you move up to this tax bracket, which says you're going to pay $850 plus 15% of everything over $850, which means you have to take your amount and subtract the $8,500 because you're already paying the $850 tax. Oops. You're already paying the $850 tax. Okay? And that is if you are greater than $8,500 but not over $34,500. Okay? So this one would be your X is between $8,500 and less than or equal to that. So it's really simple. You really are just writing this equation. It's this plus this times X minus this. This plus this times X minus this. This plus this times X minus that. This plus this times X minus that. This plus this times X minus that. That'll get your values. And then for this side, all you do is you stick your X in between these two and put your inequalities, and you're good to go. Okay, so they've done these first three. They want me to fill in the missing parts above. Well, so this one would be, like I said, it would be the 42,449 plus 0.33 for 33% of everything over 174,400. And that's if your money is between 174,400 and 379,150. Okay, so down here it's going to be the 110,1650 plus 35% of anything you make over the 379,150. And your restriction is if X is bigger than that. And so they write that one that way. Okay, and then they want me to find and interpret T of 20,000. If you are, they're saying you've made $20,000. So you got to figure out where that puts you. And that puts me right here. I'm between 8,500 and 20,000 is between there. So I'm using this equation, which says I will pay $850 plus 15% of 20,000 minus 8,500. So if I type that in, 850 plus 0.15 parentheses 20,000 minus 8,500, you get $2,575. That will be the tax that you owe for earning that much money. Nice, right? You earned it. You got to pay taxes on it. Kind of sucks, but that's our country. Alright, so this one says, one internet service provider has the following rate schedule for high-speed internet service. You have a monthly service charge of $18. Okay? Your first 50 hours of use is free. So if I set that up, my cost will be $18 as long as my time is between 0 and 50. Then after that, it's going to be the 18 plus 25 cents for every hour over 50. Okay, and so that would be as long as my time stays between 50 and 100. Because the first 50 are free, next 50 would put me up to 100. Your arrows point left. After that, it's going to be 18 plus $1 for every hour over 100. And that would be for my time that's between 100 and on. I mean, you could write it like this, but that's just silly. So instead of writing it like this, they say for any time over 100. There's my piecewise function to represent the cellular plan. Okay, so it says, what is the charge for 50 hours of high-speed internet use in 1 month? 50 hours is less than or equal to 50, so my cost for 50 hours is $18. There's no math to be done. For 75 hours, that puts me in this bracket, so my charge for 75 hours will be the $18 fee plus 25% for 25 hours. That's how much over I went from my 50. So if I type that in, 18 plus 0.25 times 75 minus 50, I get $24.25. For 135 hours, that puts me in this bracket, so the charge for 135 hours is going to be the $18 plus $1 times my 135 minus 100, because I went 35 hours over. So 18 times 35 basically is, 18 plus, my bad, is going to be $53. I hit times, silly. And your bill was $630. And I was like, whoa, no, plus. Okay, 18 plus 35, $53. All right. Now we have another piecewise function called a step function, and it's because their graphs form discontinuous steps. I mean, they're not really connected, but they call it step function because you can kind of, if you connected the dots, which you never do, but if you connected them, you can see they look like stair steps. Okay, that's why they call it the step function. It's actually called the greatest integer function, and they symbolize it by int x, or they put these brackets on there, and that one's kind of like a fuzzy one on the end. Okay, and what it means is to find the greatest integer of x. It's the greatest integer that is less than or equal to x. What that means is you always round down, always. If you have a decimal, round down. I don't care if it's over 5, whatever. The greatest integer of 1 is 1. The greatest integer of 1.3 is 1. The greatest integer of 1.5 is 1. The greatest integer of 1.9 is 1. You always round down for the greatest integer. And what it means is, it's what is the integer that number is closest to without what is the greatest integer that it's closest to. I mean, 1.3 is between 1 and 2. It's closer to 1. That makes sense. 1.5, that's halfway in the middle. 1.9 is obviously closer to 2. Okay, but I can't go past this whole number. So the greatest integer that it's closest to without going over is 1. Okay, 2 would be going over the amount. I can't go over. So for example here, the greatest integer of 2 is 2. 2.3 is 2. Greatest integer of 2.5 is 2. 2.9 is 2. You always basically round down. Okay, and you end up with these functions. And the easiest thing to explain this is the post office. If you've ever mailed actually a letter at a post office, which I don't know who does because everybody emails anymore. But anyway, if you had to go to the post office, they weigh your letter, and you have to pay based on the weight of what you're sending. Well, what this would say, if this was the price range for the post office, this would say, let's call this ounces. Anything between 0 and 1 ounce, not including 1 ounce. Anything up to 0.999999999 ounces would cost you nothing, according to this graph. Okay, as soon as you hit 1 ounce, all the way up to 1.9999999, that would cost you $1. Anything that weighs exactly 2 ounces up to 2.9999999 will cost you $2. Anything from 3 to 3.99999 costs you $3. Once you jump to 4, then you jump to $4. Okay, it's never this simple, but that's kind of what it says. Okay, all right. So it says, let f be defined by the following graph. Find, oh, this looks like a mess, but it's really not. These are all going to come out to be whole numbers. So I've got the square root, f of negative 1.5. If I go to negative 1.5 and go up to the graph, the y value is 1. So f of negative 1.5 is 1. Plus f of negative 0.9. Negative 0.9 is right here, right? And if I read the graph, that is 0. So plus 0. Big square root. Minus bracket f of pi squared. Well, f of pi is 3.14, so it's about right there. If I go down, that puts me at negative 4. So this is negative 4 squared would be 16. F of negative 3, if I go to negative 3, go up to the graph, the y value is 2, so plus 2, divided by f of 1. If I go to 1 and I read the graph, I have to go, it's not negative 1 because it's open there. I have to go down to here, so it's negative 2 times f of negative pi. Negative pi is negative 3.14 up to the graph, gives me a value of 3. Oh wait, that was in brackets. Okay, so 1 plus 0 is 1, the square root of 1 is 1, minus 16 plus, I've got to do order of operations, 2 divided by negative 2 is negative 1. I got to multiply next, that's negative 3, so 1 minus 16 minus 3, negative 15 minus 3 is negative 18. Okay, kind of crazy, you would never, there's no reason to ever do that math, but they're just trying to show you that you just end up with whole numbers. Alright, so now let's look at a real kind of problem. It says the figure shows the cost of mailing a first-class letter f of x as a function of its weight x in ounces. Use the graph to answer the following questions. So basically anything from 0 to 1 ounce costs you 45 cents. Once you hit anything over 1 ounce, like 1.000001, whatever, up to 2 ounces costs you 65 cents. From 2 ounces to 3 ounces costs you 85 cents. Just be careful. If you're exactly 1 ounce, it's going to be the 45, not the 65. If you're exactly 2 ounces, it's the 65, not the 85. You got to go with the closed circle. So it says find f of 3. Well, here's 3. I go up to the graph. There's 2 points, one open, one closed. I pick the closed. That y value corresponds to 85 cents. And it means that if your letter weighs 3 ounces, it will cost 85 cents to mail. Okay, and then this one says, what is the cost of mailing a letter that weighs 1.5 ounces? Well, if I go to 1.5 ounces, 2, 4, I don't know what they're counting by, I don't know, right there in the middle maybe. Alright, and I go up to the graph, that's right there, so it's going to cost me 65 cents. Yeah? Alright, this one says, furry finances. A pet insurance policy has a monthly rate that is a function of the age of the insured dog or cat. For pets whose age does not exceed 4, the monthly cost is $20. The cost then increases by $2 for each successive year of the pet's age. The cost schedule continues in this manner for ages not exceeding 10. The cost for pets whose ages exceed $10 is $40. Use this information to create a graph that shows the monthly cost of the insurance f of x for a pet of age x where the function's domain is 0 to 14. And I didn't make my graph big enough, but anyway. Okay, so if your pet is between 0 and 4, but it can't exceed 4, so that means it can't be included, okay? Then your cost is $20. So if I graph that from 0 to 4, it's $20. And what was I thinking about my y-axis? Alright, let's change this. Let's call this $10. Let's just start at $20. We'll do a little hiccup in my graph and call this 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. Yeah? And I'm supposed to do this to 14, and this graph isn't big enough. Well, darn it. Let's count by 2. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So anything between 0 and 4 years of age is $20. Okay, now we got to get our circles right. The line is easy. 0 to 4 is $20. Now you got to get your circles. 0 is included, and 4 would be open. Okay? So, let me get our color straight. If your pet is between 0 but not over 4, your price is $20. Okay, so let's switch colors. Now, if your pet is between 4 and 5, and it can be equal to 4, but it can't be equal to 5 because it can't exceed 5, then your cost goes up to 22. So from 4 to 5, darn it, now I don't want to count by 2. So from 4 to 5, darn it, I don't like my graph. From 4 to 5, it's $22. This one would be closed. This one would be open. Okay. Let's switch colors. From if your pet is between 5 and 6, then your cost goes up to 24. And again, you can be equal to 5 here, but you can't go over 6. So again, from 5 to 6, there's going to be your lines. I really wish I'd used a different graph. You know what? I'm going to switch this, guys. I'm going to go back to counting by ones. We just won't be able to go all the way out to 14. Actually, yes, we will. Just try another stupid graph. Sorry, I really want you to get a good visual of this, and I did not pick a good scale for my graph. Okay. So 20, 22, 24, 26, 28, 30, 32, 34, 36. Well, might get better. All right. 0 to 4. Oops, sorry, I forgot to count. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So from 0 to 4, we got 20 bucks. Okay, this one's closed, that one's open. From 4 to 5, we got 22 bucks. Closed, open. From 5 to 6, we got 24 bucks. Closed, open. And guess what's going to happen? We're just going to keep doing this over and over and over again. So the next jump would be, well, up until 10. Okay? So the next jump would be between 6 and 7, less than or equal to, less than, your price goes up to 26. So at 7, it's going to be 26, closed. 6 to 7 is open. My lines are getting too long here. 6 is going to be closed to open. Okay. Next, we're going to do 7 to 8, and that would bump me up to 28. So 7 open to close is 28. Then I'm going to do between 8 and 9. That's between 8 and 9 would jump up to $30. So from 8 to 9 is $30. From 9, oops, switch colors. From 9 to 10, we're going to jump up to $32. And now finally, from 10 on, it says the cost schedule continues in this manner for ages not exceeding 10. The cost for pets whose age exceeds 10 is 40 bucks. So for X over 10 exceeds 10, then your price jumps up to $40. So once you reach 10, it jumps all the way up to 36, 38, 40. Jumps all the way up to here. Right? And this one would be closed, and it would go forever that way. After 10 years old, you got a straight fee of 40 bucks. And that would be my step function for these furry finances. Alright, so how do you interpret or read a greatest integer function? Basically, round down. Alright, so we are at homework, which means we are done. Happy homeworking, and I will see you next time.